Hi, it's time for another math easy solution to discuss further into shifted conics and now look at example 4, which looks at the hyperbola. So let's just jump right in and go over this example, which states sketch the conic 9x squared minus 4y squared minus 72x plus 8y plus 176 equals to 0 and find its foci. So yeah, it's quite a long example right there, or long formula over there. Yeah, now while this seems all long there, but recall my earlier examples on shifted conics that we could simplify this and then complete the square for both, in this case x squared, or for the x and y variables. So what we'll do now is let's just simplify the whole thing. Let's simplify. And first I'll just write down that formula. So we have 9x squared minus 4y squared minus 72x plus 8y plus 176 equals to 0. So we have this right here. Now what I'm going to do is I'm going to just put all of the x's together. Right here 9 and this 9x squared and this negative 72x, and I'm going to factor out. I'm going to just try to simplify and factor out with what I can. But here we can see 9 goes into 72. That is just 8. Because 9 times 9 is 81. So 9 times 8 is going to be, well, 81 minus 9. That's 72, like that. So what I'll do here, and also this one, I'm going to move this over to this side, and then I'm going to put these x together, and then also do the same for the y. So what we get is 9x squared minus, now here's going to be 8. So I'm just going to simplify that. Oh, there's an 8x, like that. And I'm going to do the same for this one right here and this right here. So in this case here, what I'm going to do is I'm going to take out a negative 4, because then we have 8 in there, so that becomes negative 2 there. So we have minus 4. Yeah, we have minus 4 and then y squared, and then right here is going to be negative 2y, and then this one's going to be on the other side, negative 176. And now what I'll do is, well, this is negative there, we could just multiply by negative on every side. So I'll just do like something like this, times it by negative 1 over the whole thing. So then what we'll have is this one's going to be positive, this is going to be negative, and this is all going to be positive there. So I'll do that right here. So what we'll get is a 4y squared minus 2y, and then this is, this is going to be positive, this is going to be negative over there, minus 9x squared minus 8x, like that, equals to, over here, 176 positive. Alright, so now that we've written it like this, and I'll just box this out, so we have it simplified to this way, so all the x's are one side and the y's as well, like that. And now recall from my earlier video on completing the square, so recall on completing the square, and what we're going to do is try to write this in a typical conic formula. Let's write completing the square. So what we want is, we don't want this y squared and this y, we want it to deal with just one variable. So what we do want is something like this, x minus a and then squared. Let's put it like this, x minus a squared. If you expand this out, this just writes the same thing as writing x minus a times x minus a. So this is just a square. This times it by itself. This equals to, well, this times this is going to be x squared. X times negative a is going to be negative ax, and then negative ax times negative a times x, that's just again ax, negative ax, so that would be 2, add them up, and then likewise negative a times negative a is going to be plus a squared. So now what we get is, well, we get this form right here, x squared minus 2ax. That's very similar to these ones, x squared minus 8x, and then we just move this on the other side. So this is what we want, and we can move this over to there, or I should just move it all the way over to here. So this is what we want, this is what we have. So what I'll do is write this all in terms of this. So this is going to be x squared minus 2ax is equal to x squared minus a squared, and then plus, or minus now, minus a squared. So now that we have this part here, and I'm just going to put this in a little bubble like that. So what we have is this. This is what we. This is the formula we're gonna basically use, and now we're gonna simplify this. So for this one, so x squared minus 8x, we have 4. Then we write x squared minus minus 8x. Let's write this neater. So 8 squared minus 8x. In this case right here, if you want to align it with this means, well, we have 8 equals to, this is the 8 equals to 2a. So in other words, a is equal to 4, like that. So that's what we have over here. Yeah, so a equals to 4. So thus, plugging in this formula there, we have this x squared minus 2 times a times 4. X is equal to over here. So that's going to equal to x minus 4 squared minus 4 squared, like that. This equals to, well, now what we have is our x squared minus 2 times 4 is 8x. Like this is equal to, and now this is going to be equal to x minus 4 squared minus 16. So that's what we have. Yeah, so this is now going to replace this part right here. And the same thing for here, we could do that as well. So 4, alright, for the case, now for the y one, so y minus, y squared minus 2y. So we have y squared minus 2y. Now in this case, we're just going to use y instead of x, but the same thing applies. So we'll just write y is equal to x, like that. Or just y is identical to x, or the other way around, we're just going to say the x in the above formula is identical to y. Either or. Anyway, so now in this case what we have is our a. So that's negative, that's just going to be 2a equals to 2. So in other words, 2 equals to 2a. We get a equals to, well, this just cancels a equals to 1. So thus what we have is, now we have the y squared minus 2ay, because we're replacing x with y. So 2a is 1 times by 1 times by y equals 2. And now this equals to the, now instead of x, y squared, just y, minus a is 1 squared, then minus a squared, or 1 squared, like that. So that's what we get over there. Now this just simplifies over to y squared minus 2y is equal to y minus 1 squared minus 1, like that. So this now replaces, so we've completed the square, this replaces the top part over here. So now we can have just one variable for each. And then let's put that all together. Yeah, so thus what we have is, let's write the old formula for y squared minus 2y. And then we have, if we recall, this is going to be subtracted by 9. And then we have the x squared minus 8x. So that's, let's look at here, 8x, like that, and equals to 176. Minus 8x equals to 176. And now what we'll do is, and I'll just write this formula above becomes, and then we just write 4, and now this one replace it here, put this in brackets, like this can be 4y minus 1 squared minus 1, like that. And then minus 9 times it by the x squared minus 8x is x minus 4 squared minus 16. So x minus, like this, x minus 4 squared minus 16, like that, equals to 176, like that. So we can multiply this inside now and simplify it further, so we get 4y minus 1 squared minus 4. This one here, minus 9 times x minus 4 squared, the negative 9 times negative 16. Yeah, this just becomes plus 9 times 16, and then this whole thing equals to 176. And I'll just do a note right here. Note right here, 9 times 16. Let's just do that right here by manually. So 9 times 16. 9 times 6 is going to be, that's actually 54, because number 9 times 9 is 81. 9 times 8 is 72. 9 times 7 is 63. So you also go down 1 and then increase on the right digit. And then 9 times 6 is 64. And likewise, 54. And then 9 times 5 is 45. and so on. So this is 4, 5, 9 times over there. Or you could even do 10 times 6 is 60 minus, and then you just minus minus 6, because you were multiplying 10 6 times, so you always have that extra 1. So 60 minus 6 is 54. So just do that in your head. 9 times 1 is just 9, and then plus 5, so that's going to be 144, so 14 like that. So then this one right here goes over there. This is 144. And now what I'm going to do is I'm going to move this 4 all the way to this side, as well as this, move it over there. So then what we end up having is, let's put this like this. This becomes, now we have 4y minus 1 squared minus 9 times x minus 4 squared equals to 176 minus 144, and this one's going to be plus 4 like that. And now on this side what we could do is just simplify this. So this is the same thing as 176 minus 144 plus 4. That's just going to be, well, minus 144 plus an extra 4 becomes 140, because it's minus, so you want your plus, becomes like that. And then you could subtract this, so the hundreds, you could just do this in your head. Yeah, this is just 176 minus 140, so that's the same thing as 76 minus 40, and then that's just going to be 36. So 140 plus 36 gets to this. So this equals to 36. But also notice how this is 36. This equals to as well 9 times 4. Yeah, remember 9 times 5 is 45, 9 times 6 is 54. So every time you increase the left digit, the right digit decreases. So this is 9 times 4, and the reason I'm running it like that is because now what we could do is, well, on this whole, we can do it on both sides like this. So what I'll do is divide everything by 9 times 4. Yeah, so 9 times 4 everything. So what we end up having is, on this side here, divided by 9 times 4, the 4 cancels like that. We have a 9. So what we'll do is, this becomes, the 4's will cancel, so y minus 1 squared over 9. Then minus this one here, the 9's will cancel, and we'll get a 4. So what we get is x minus 4 squared over 4, like that. And now this side here, we're dividing by 9 times 4. I'll just do it like this instead, actually. So we'll do that on both sides. So I'll just go like this, divided by 9 times 4, and then divide this by 9 times 4. Let's do it a bit further, say to a signal we're doing it again, doing it afterwards. Divided by 9 times 4, and then this one divided by 9 times 4. So doing it on both sides, we're not changing the value. And then as you can see, this cancels, this cancels, this cancels, this cancels. And that's what we're left with. This cancels, equals to 1. So this becomes 1 like that. And there is our formula for this this conic section, or this is conic. And now what we have, this one you could also write this as or, and this one's going to be, well, y minus 1 squared over 3 squared, and this one here minus x minus 4 squared equals to, divided by 2 squared, like that, equals to 1. So either or how you write it. And this is a hyperbola. And now this is a hyperbola. This is a hyperbola like this. Amazing. And that's because it's we have a subtraction over there. So if we add, it becomes a positive, but if we're subtracting like this, and this is actually a vertical hyperbola, because we're doing y is the positive one, this one's negative, like that. This is a vertical hyperbola. And the way this would look like, but then we're going to be shifting it though. So recall a vertical hyperbola. It's going to look something like this, but we're going to be shifting it though. So it's going to look something like this. Let's put it over here. X, Y. This is going to look something like this, but then it's going to be shifted over. So it looks something like this, where it has asymptotes across, like this. These are the asymptote lines. Let's write this over here. Asymptotes, like that. And then the foci is going to be somewhere over here. This is C and negative C, and these are the foci. Foci and foci as well. And then this part right here is the vertices. These are at A, negative A, and this is at A, like that. This is the origin right here. 0, 0, like that. Also, I'll just put a 0 over there. Or I'll just put an arrow, then put it. Yeah, this is a bit neater. Like, yeah, put an arrow and draw it. So 0, 0. So we have that. This one is the vertices, like this. Vertices. And that's this one as well. So now what we'll do is, but notice this, we're shifting it though. So it's going to look something like, well, we're going to shift it actually, if we recall, this is the y is going to be 1, the x is going to be 4, so it's going to be look like, instead of the origin is going to go y1, let's just say somewhere over there, it's going to look something like this. It's going to go up 1 and then 4 to the other side, so we're going to be shifting, so shift. And then when we shift it, and then then when we shift, I'll put this in red, it's going to look something like this instead. So everything's going to shift along this, like that. And then again, we have a new asymptotes like that, and then a new origin, depending on, just a new origin. Exactly where we shifted it. Or a new center here, just fix it up something like this. So it's going to look something like that over there, and then we're going to have everything gets shifted across. The foci is going to be here, and this one's going to be here somewhere, and then we have a new vertices, and so on and so forth. So what we have there now is, now what we're going to do, let's write this as C, A, and this is one's going to be our new H and K center as opposed to 0, 0. And this one here is going to be the negative A. This is going to be the, over here is going to be C. And it's going to be all shifted over to here. So this one's actually going to be, it's going to be the horizontal distance going to be H. So I'll just put this as negative C anyways. And now what we'll do is, just get all these values and shift them. So, and also the formula for the left one here. So what we'll do is recall. So recall my earlier videos on shifted conics, and in particular the shifted hyperbola. So shifted conics, what we have is, this is the normal formula for a hyperbola, y squared divided by a squared for a vertical one, then over a squared, then minus x squared over b squared, like that, equals to 1. And then what we'll do is, well, we're going to shift this over to here. I'll write shift. And then we're going to shift this all the way to here. And now what we get is the formula over here. This is going to be, I'll just write this like this. So we shift this, the new formula is going to be y minus k, y minus k, like that, over a squared, and then this is going to be x minus h over, x minus h squared over b squared equals to 1, like that. So when we shift all this, what we end up getting is, over here we get, what we get here is, let's just write for each of the terms. So the center is, originally it's 0, 0. That's this point right here, the center over there. That's just the origin. Now here goes to H and K. So when we shift, this becomes now H and K is the new center, like that. And likewise, now for the vertices right here is at A, or is at 0 and A, and negative A as well. So vertices 0 and plus or minus A, like that. Now this gets shifted over to, now it's going to be, instead of 0, what happens here, because this is 0, negative A, like that. The vertices are all going to change its values because we're shifting the whole thing upwards. And these new values, A, C, and stuff, these are all relative to this over here. So this distance like this is going to be our A. This is going to be our, right here, A. So we're going across it like that. And in other words, to get the coordinates, this one's going to be added by H and K to that new value over there. So in other words, the vertices, instead of going from 0 plus or minus A, now it's going to go all the way to the right by H. So it's going to go to H, and then it's going to go upwards by K. So we're going to have K plus or minus A, like that. So those are the new values across here. So this one's going to go right by h and upwards by k, and so on. And that is the vertices, and same for the foci, and this is going to be 0 plus or minus c for the original. Then we're going to shift this over, and now it's going to be over here, it's going to be h and k plus or minus c. Let's put that in front. And also recall that c squared is equal to a squared plus b squared. In my earlier video. Yeah, so that's what the c squared is equal to, and how it's related to the b value in the formula like this. And also recall that the foci right here, this is such that the definition of a hyperbola is defined where any point on it, for example here, the distance from here to the foci, and the difference between here to this foci, this difference is always constant. So this minus this is always going to be constant, or this minus that. It's going to be the absolute value is going to be constant. So it's constant difference, not sum. An ellipse is a constant addition of those differences. I mean, of those distances. But this one's a difference in the distance to the foci, and that is a hyperbola. So now keep going further. The asymptote lines. So we have two of them. There's asymptote across there. Let's put the arrow like this over there, asymptote. So the asymptote lines, I'll write asymptotes. Recall that this is going to be in my earlier video on definition of hyperbola. This is going to be plus or minus a, which is the y component, divided by b times x, and just straight lines. But again, in this case, this is going to be shifted. And this one here, we're shifting an entire line, and this is going to be now, well, we're shifting it to y minus k equals to an exact same method over here, for because it's a line is still a conic, or it's just a straight line. And then now we're going to be shifting the y value exactly as we're doing it right here. We minus on the y and minus on the x wherever we want to shift it. So we're going to shift it to the k, the y, as well as now we're going to have plus or minus. Yeah, we'll just write this plus or minus a over b, and then now x is going to be minus by h, like that. In other words, this part right here is shifting a line. Or note, this is just a shifted line. A shifted line. Yeah, shifted line. So the center. So now this new center of it. So the because it's not really a center, so the center is going to be, well, this one's going to be h and k. In other words, if we scroll back up here, notice how these asymptote lines, you can think of this as a center, but now this is where these new center of these are, like that of the lines, h and k. So it just goes over there, and it's the exact same line here, but then this goes all the way over there as well, so this one as well, like that, those lines. So yeah, so putting all this together, thus in our case, what we end up getting is, I want to go over that in detail before we get to here. So thus, in our case, what we have is, and I'll just write that new shifted formula. So y minus k squared over a squared plus x minus h squared over b squared. This equals to 1. This equals to, now with the values, scroll all the way back up. Now we have 1, 4, and then 3 and 2, like that. So we get now y minus 1 squared over 3 squared minus x minus, this one is 4 squared over 2 squared equals to 1. Yeah, so now what we have with the new values are, well, a is equal to 3. Let's write a equals to 3. B is equal to 2. B equals 2, like that. And then our c squared is equal to, well, a squared plus b squared, as shown above. And now what we have is, well, this equals to 3 squared plus 2 squared. This equals to 9 plus 4. This equals to 13, like that. And then if we square that, we get c is equal to plus or minus square root 13. But we're just going to be dealing with the positive ones, like that. Just define it as positive. So that is what our c value is. And now our vertices, like this, vertices are going to be, and again it's shifted, so we have h and k plus or minus a. So we have h, and also forgot to add it over here. H is equal to here's the 4, and then we have k is equal to 1. So k equals to 1, like that. So I'll just circle all the ones that are important, like this, this, or I'll just box this one actually all together, like this. So we have h and then k plus or minus a. So what we have, h is 4, so the coordinates are going to be 4, k is equal to 1 plus or minus a, which is 3. So this equals to, well, this could be, if it's positive, we get 4 over here, 4, and then 1 plus 3, which is going to be 4, like that. Or 1 minus 3, it's going to be 4, and then minus 2, like that. So that is the vertices, or those are the vertices. And now the foci is the same, is similar, h, and then k plus or minus c. So then where h is again 4, and then we have k, which is 1, plus or minus 13, square root 13, like that. And I'll just keep it like that, just because it's easier. Yeah, easier to deal with the absolute value like that, or the exact value, as opposed to the approximation if you were to square root that. But I will square root it later once we graph it using a calculator. So that's what we have there. Now the asymptotes. So the asymptote lines. And here I boxed this one out because that is what we were asked to solve in the top in the question, was to graph it and solve for the foci. So now what we have is the asymptote lines. And again, this one here, the formula, I'll just write it just as this, like that. So y minus k, y minus 1 equals 2, and then this is plus or minus a over b. So plus or minus a, which is 3, over b, which is 2, and then x minus h, which is 4, like that. So this is our asymptote lines, like that. I'll just box this as well, like this, and might as well box this too, like that. So that is what we have over here. Yeah, now what we'll do is just graph it all together, and what I've done, I just use a calculator. It's easier. It's basically going to look something like this, but neater. So going first, let's get the values here. So calculating the foci, we get 4 and 4.606, and 4 and negative 2.606, just roughly approximate. So here, just use a calculator, and I use DuckDuckGo. So 1 plus square root 13, or SQRT 13, it becomes 4.605, and it keeps going on there. But if you minus, it gets over here, negative 2.605, and going on. So now here what I've done is, let's graph this using the amazing Desmos graphing calculator. And here is these values. I've hidden these ones right now. So here's our y minus 1 all squared minus x minus 4 and all squared, like that. And there is our asymptote lines, like here. This is a positive one. This is y minus 1 equals to 3 over 2 x minus 4. And this is the positive side. That's a positive one. This is the minus side over here. And this one is y minus 1 equals to negative 3 over 2 x minus 4, like that. And then notice the vertices are all the way right over here, and the vertices, this is 1, 2, 3, 4, and as you can see, that is the distance is 4 right here, and this one is 1, so 1, like that. And this is the center is going to be at our 4 and 1. The vertices is at this point right here. This is just 4 and 2. Negative 2. And we could see that above right here, 4 and negative 2. And also, I'll just write this here as well. Center. The center now is equal to h and k. This equals to 4 and 1, actually. Yeah. So 4 and 1. Did I get that right here? Yes, 4 and 1 at the center is over here, like that. So yeah, let's just keep going over here. So that's the center right here, And now this is the vertices. This is 4 and 4. Distances are here 4. And the focis are an interesting one. It's at 4.605. So the foci are at 4 and then 4.6 and then 4 and negative 2.6. So in other words, it's going to be at 4.6 somewhere about over here. That's the C value right there. This is at C. And then the other one's going to be at negative 2.6. So somewhere, so this is going to be negative 1, negative 2, and then somewhere across here it's going to be in between, so it's going to be somewhere over there. So there's a C. It's very, very close to the vertice right over there. Very interesting. This is our this is right here like that. Let's put a negative C and so on as positive C, and there's our A, negative A, this is positive A, like that at that point. So yeah, very, very interesting stuff. And here what I've done is, let's view how the hyperbola is shifted from the origin. And here I've graphed out in red and the dashed line for the asymptote lines where it was originally. So we have it starting here, and then we just shift this just slightly over there. Well, horizontally a lot, but vertically just by 1. And you can see every single thing is the same thing. It's gonna be it just goes up exactly the same. The origin's same. This one just goes up exactly the same, like that. The same arrows all the way down. So yes, very, very interesting stuff. So yeah, that is all for today. Hopefully you followed along this very detailed example. I wanted to go through very slowly and methodically, just hopefully I can drive home the point how to shift conics and so on, especially for hyperbola is a bit more complex than the typical parabola or ellipse. Anyways, that's all for today, especially this example, which involved a lot of completing the squares and so on and putting it all together. Anyway, that's all for today. If you learned, like always, you can download these exact notes in the link in the description below, as well as viewing these notes on Steam. And follow me at MES and check out my private Discord chat room and online math forums and post any cool math or science related stuff you find. Anyways, that's all for today. Thanks for watching and stay tuned for another Math Easy. So